Okay, so now we're going to look at some exponential modeling. We're going to try to be able to write an exponential function to model a scenario that's been given to us. I've got a formula here on the board. I'm going to go ahead and explain what each of these things stands for. We'll start with this lowercase a. This lowercase a is our initial amount, or how much we're starting with. This a of t over here is the amount after so many time periods. So this is kind of like our result. How much we want to end up with is this a of t. So that would be the amount after t time periods. Going off of that, t is the number of time periods. So maybe we're talking years, hours, whatever, for the certain scenario we're talking about. And then this r is your growth or decay rate, like that. If it is growing, then r is a positive value, so you'll have some plus some percentage as a decimal there. For instance, 5% would be 0.05. So if something was growing at a rate of 5%, I would have 1 plus 0.05. If something was decaying by 5% per year, I would have 1 minus 0.05 for that. So let's look at an example here. We have a problem that says you've invested $1,000 in a savings account at the end of 6th grade. So let's go ahead and plug in what we know. Our initial amount is $1,000. And then it tells us, as we continue to read the problem here, it tells us that the account pays you 5% annual interest. So it's going to pay you 5% per year. And it wants to know what the value of the account is going to be after 6 years. So I'm going to go ahead and just set up the function first. So I have a of t equals 1,000 times 1 plus. It said it's growing at a rate of 5% per year, so I will add 0.05. Again, 5% as a decimal is 0.05. Divide by 100 to convert your percentage into its decimal equivalent to the t power. So there's my function that models the scenario. So pay attention to the directions in the problem. If the problem asks you to actually write a function that models the scenario, you better actually have this function written down instead of going one step further and already plugging in the value. Now, to answer the question, it wants to know what the value of the account is going to be after 6 years. So then we'll go ahead and plug in 6 for that. So we have a of 6 equals 1,000 times 1 plus 0.05 to the 6th power with that. So at this point in time, I'll go ahead and compute that. I have 1,000 times 1.05 to the 6th power. I'll go to my calculator, and I'll compute that. 1,000 at 1.05 to the 6th power. And that is approximately $1,340.10. I'll round the 2 decimal places there since we're dealing with money and a value in an account, and the problem didn't say otherwise, so that would make sense in terms of money. So there's a problem where we had to set up an exponential model. We had to know the initial value. We had to take our growth rate to go ahead and create this growth factor of 1.05, and then we had to go ahead and plug in our value of 6 to find the value of the account after 6 years. So